We're waiting to get going there. That was interesting about the just the question on the marketing position. Last year I advertised at the same time for two different jobs. So I placed one ad for a marketing coordinator, and at the same time I placed an ad for a mining engineer. I got 155 applications for the marketing job and 0 for the mining engineer. So it really shows you where the shortages are when you just one-off examples like that. So walking around yesterday, I don't think I met any other mining engineers, so I wonder if I might be the only one in the room. Is that the case? No colleagues here? It's kind of interesting, and you do come across that a little bit in training as I've started to get more involved in the training side of things. I guess I've noticed that a lot of the people who are involved in training and control training budgets quite often from a HR background. But the person that they need to convince in a mining company quite often ends up being a mining engineer. And I guess we have a certain way of looking at things around business cases. And really a lot of what I want to talk about today is the lens through which I look at training investments and business cases for training. So hopefully what I talk about will be of use to some of you when you're trying to motivate for training budgets. Because when we look at where we've arrived at in the industry, I think certainly in the medium term, training will be a big part of the answer as to where we get some productivity improvements from. So on that theme, I really want to talk about 3 different areas that I think we can bring together to build an argument for training. So one is the use of benchmarking in the broader sense, comparing one operation with another. The second one is the individual data and information you can collect within a site. Quite often there's a lot of information around equipment and people and productivity that's collected but not really analysed or tied together into a strategy. And the third element is skills training, and then how can you use that and measure it continuously and achieve a productivity improvement, which is really the thing that we're all looking for at the moment. So just a little bit of an overview of what I'll go through today. So one, I'll use a couple of examples in terms of the size of the prize. If we could get a productivity improvement at a typical mine, what kind of dollars are we talking about? What sort of improvement would that give us? Where to focus the effort? It's one thing to understand if I could get a 5% productivity improvement, what would that mean? It's another thing to figure out where you're going to get that from. And that involves analysing data. So I'll give you a couple of examples there. And thirdly, what can we do differently in skills training? That will give us a bit of a jump. Obviously, if we just continue doing our training the same way we are now, then ostensibly nothing's really going to change. And I'll just touch on very quickly at the end a couple of examples on future technology and where it's all headed, and some examples from other industries that we can look at. So just in terms of the backdrop and where we're at, I think this is a common story in the papers and familiar to everyone, but certainly the price boom that was driving profits, I think we can see that's over, although historically prices are still pretty good. So with good prices, why are some of our operations struggling, particularly in Australia? Really it's about our cost base. It's risen very quickly over the last 10 years especially. There's no way out of this with investing in new capital. I think most companies have got a tight rein on capital spending right now. We hear a lot about automation, and it's a great avenue to productivity gains. But because it's capital intensive, relatively new, typically if you want to make advantage of that type of technology, you need to design a mine especially for it. It's going to take time for that to flow through in the industry. So what that really means is that any improvements in productivity largely have to come from the equipment we've got and the people that we've got. So for that reason, I think the next 10 years you'll see a lot more focus on using training as a way of improving productivity. This was just something I came across in the paper on Wednesday actually, which is an example from Canada, so it's really not just us. This is a quote from the president of Shell Canada, which has big oil sands operations and large truck fleets and so on. And so the story there, we've been in a growth period for 10 years, sounds familiar. This decade will be focused on operational excellence. We're taking a step back to make sure that we're really efficient. I think it's a good summary of pretty much exactly how things are seen by most of the large companies, especially for their operations in Australia. So moving on to just understanding, like I said, what's the size of the prize for a typical mine? What kind of improvements could we see? And what sort of variance do we see out there with different people using the same equipment? So this is a comprehensive set of data that's put together by a company called GBI, who've kindly made some data available for me for today. This is data points for a Cat 793 truck globally, and they have statistical methods to normalise the data so that it's not impacted by the length of a haul route or the density of the material that they're moving and that sort of thing. So this data shows on the bottom axis the production time that different sites achieve with that particular truck, and on the vertical axis the annual output, tonnes on a normalised basis. And you can see it's quite spread. If I can find my pointer here. There's data points that really range from the top to bottom on these scales in both directions, but you get a bit of a cluster and a bit of a trend through here, as you'd expect. So that the more time you get out of a truck, the more material you can move. Makes sense. But the interesting thing is that basically for one truck, same thing on every site, if you move between 25th and 50th quartile, you can get a 3.7% productivity improvement with that type of truck. Go to the next quartile, 3.6%. And actually best practice, you can get another 9%. So they're quite big numbers really if you think about a mining operation. And let's say you're operating at the 25th, if you could just get up to the 75th, you don't need to be best practice. You're going to get a 7.5% productivity improvement. It's massive dollars. So that's a Cat truck. Another popular one is a Komatsu 830E, just to test whether those sort of numbers are typical. You see, actually, it's interesting. With the Komatsu truck, you get a much closer correlation between the operating time and the productivity. I have no idea why that is, but it's just an interesting thing that comes out of this type of data. But if you just look at the quartiles, very similar, 3.2, 3.1. In that case, best practice, not such a big leap. That's kind of interesting. But if you looked at that case of going from the 25th to the 75th percentile, again, 6.4% productivity improvement. So same truck, it can only be the way that it's operated and the way that it's maintained. Just to look at some different types of equipment, so obviously truck fleets are important. They're coupled to loaders, clearly. So we're looking here at a Liebherr 996, which is a popular type of excavator. And the interesting thing here is it's a higher skilled job. It's a harder job than driving a truck. And what we find with these machines is that rather than being around 3%, 3.5% between quartiles, it's actually 10% on this machine. And if you can go from the 25th to the 75th, 21%. So a much wider variation in performance using that machine compared to someone driving a truck. And again, just look at a different brand and see whether we get some consistency on the data. This is a Hitachi 5500, another popular excavator. And that's even bigger, 15% between quartiles. And if you go from 25 to 75, you're looking at a 32% difference in productivity. Same machine, just different people driving it and maintaining it. So those two things really come together. So percentages are all good to work with, but they don't really give you a feel for the numbers. So what you've really got to look at, well, what does that mean in the context of a particular mine? So this is public data published by Newmont that are the last quarter's production statistics and mining costs for Boddington, which is, a very large gold mine. So if we look at these sorts of improvements in the context of a large mine, if you could just improve their truck fleet by 1 quartile, and that mine would be worth $16 million a year in additional profit, which is a big number. You can do a fair bit of training and get a good return on investment if you can reliably think I'm going to achieve that kind of a number. If you could get the shovel operators up 1 quartile, you're looking at $46 million a year. Huge amount of money. But a very big mine, so you get a big return for a fairly small percentage. So to look at another example, this is a Hunter Valley thermal coal mine. It's a little bit harder to find cash cost data that's publicly available for coal mines, which is interesting because I think a lot of them are operating pretty close to the line at the moment. So I made a couple of estimates on this one around their cash costs. And this is a mine moving at probably a quarter of the material of somewhere like Boddington, and obviously a different commodity. But still, 1 quartile on the truck fleet, almost $2 million improvement, and this is going to be sustained annually. And if you look at that 1 quartile improvement on trucks, on loaders, you're looking at around $5 million a year. So if you're close to the wire with profitability, those sort of numbers can make quite a big difference. But as I said earlier, that doesn't really help you if you don't know where you are behind in terms of your benchmarking specifically and what you can address with training. So where do you get this data from? Well, if we're looking at mobile fleet, most modern mines do have quite sophisticated fleet management systems for collecting data around cycle, as well as onboard technology for equipment health, and usually pretty rich data around availability, maintenance costs, and all these sorts of things as well. So usually the data's there. Quite often it can be in one large database from a fleet management system. But what tends to happen is a lot of it ends up on the shelf or gets used once a year with a vacation student doing a utilisation study or something like that. Very rarely connected in with what could be an opportunity around training. So I'll give you an example of a case study where some of this data was analysed on a particular site. So this was actually a dragline problem, and the site was achieving 9.66 million bank cubic metres per year, and that's 42% below best practice for that particular machine. So quite a big gap if you wanted to get to best practice. And analysing all of that data from all these different sources, 37% of the difference was in basically how much material was being put in the bucket. And then, a smaller amount in the number of cycles, which is really an operator training type issue. So if you look at the specifics of where the issues were, and this is just sort of the top 4. The bucket design itself, operators not really knowing how to fill the bucket. This one about suspended load is really to do with some issues that were discovered around the electrics on this particular machine, and one where the digging was just hard. So if you look at the training opportunities there, certainly number of cycles, that's just how you're operating the machine. Not filling the bucket, obviously you can teach people to achieve that. And even the one on the hard digging, different people responsible, but that's really about understanding how to design a blast to get the right fragmentation. So you're talking about training the blasting engineer, not the operator in that case. So the solutions that were designed in this particular project. So I'd mentioned the electrics. So there was some work done on the electrics of the machine so that it could pull the bucket out of the ground easier. There was a new bucket designed and some changes to the rigging. There was some work done to improve blasting to deal with this fragmentation issue. There was operator training, so it was a part of the solution. And they started measuring these results consistently and reporting them. And the achievement on this particular case was 28 tonnes for the average payload of the bucket, which was $53 million in additional margin annually. So again, a sustained improvement. And just highlighting the areas there where training was a part of the answer. So another thing I wanted to go into today was specifically on the training aspect, and a case study again, actually from oil sands in Canada in this particular case. And this case study is around implementing a blended learning solution for truck drivers. So basically including data that you can measure, self-paced learning at the beginning, instructor-led learning in classrooms, including simulators as a part of the program, and retaining the on-the-job portion of the training, which I think will always be important. So this one is from Suncor Oil Sands. As I said, haul trucks. The nice thing about this case study is it was done quite scientifically. So there was a control group. They had 2 shifts of new operators come in that were just trained the normal way, and 2 other shifts that came in who were trained with a redesigned blended learning program. And the results were measured over 4 months. So, obviously they embarked on this experiment for a reason. So these were the reasons. They were undergoing a mine expansion, so they did have these new operators coming in, and quite a few of them to be trained up. The existing training system was basically, I guess you could call it a brain dump. So it was several days in a classroom being, fed all the rules and the information. And the issue was, while people could beat the test at the end of the day or the end of the week, they really were just forgetting it by the time that they'd spent a week or 2 out in the workplace. A lot of the content was kind of rules-based. Do this, don't do that. But adult learning, people do retain information better if they understand why. So that was one of the issues. And the last one there, probably, but not the least, is that no one had trained the mentors. So they had this buddy system for the on-the-job part of the training, pretty much a one-to-one, but no one had trained any of the mentors or told them what they were expected to do. So there was massive inconsistency there with the type of feedback people were getting or what the mentor even did. So for the experimental group, a new training system was designed, and you won't be able to read it, but that's a representation of the training there. And essentially, there was 2 main changes there. One is that learning was done in chunks, so you'd concentrate on a topic, both in theory and on the job, and in some cases practicing in simulators, and you would attain a competency and that skill before you moved on to the next chunk of learning. So rather than having all the theory thrown at you and then thrown out on the job training, it was done in bite-sized pieces. Another thing was, apart from the chunk learning and the simulation, there was actually an expansion of the curriculum that included other topics like the environment, maintenance, where you interact in your job with other parts of the operation. Training was introduced for the mentors, only for these experimental crews. And the on-the-job training was retained. So that's represented by these red boxes here. So this just represents the first week of training, this particular picture. But you can see every day they went out still with a buddy system on a truck. And so not to spend too much time on the detail of it, but the results were, after 4 months of measurement on the work site, the people who'd been trained on the new blended learning system had 3.5% higher productivity. which is interesting because you go back to the data that we looked at before, and that's pretty much exactly a 1 quartile improvement in terms of productivity from that truck. So it's a really neat case study that shows if you train people better, you can move up by 1 quartile. Really reinforces that, and for each operation you'd have to look at the amount of money involved there. It's certainly significant. But the other interesting one is that the number of safety-related incidents that they had with those crews was 50% lower, which is a huge number. So the focus of this talk really is around the productivity argument and the amount of money involved. But as you all know, mining companies place safety very highly. It's always the first, and to have that kind of achievement through this kind of training, we probably do need to just explore that safety aspect just as a bit of a segue. So 50% improvement, quite big. If you look at practices in other industries and the use of simulation, I think it's got a fair bit to do with it. And the issue is that if you're not using simulation in training, you're really only doing a third of the training. So if you're in a buddy system on a truck, you're only practicing normal conditions. You're not going to practice driving too fast, downhill, fully loaded, on a wet road, come around a blind corner and have a utility parked across the road. You're just not going to practice that in the real world, but you can practice that in a simulator. And that type of learning really, it does two things. It really brings it home to people, the implications of driving too fast or whatever the particular issue may be. But it also gives them the experience of how to react. So there may be situations where they haven't done anything wrong, but if you've practiced an unexpected scenario a number of times, then you're going to react the way you should if you ever come across it in the workplace. And this is nothing new. If you look in aviation, every pilot has practiced dealing with an engine failure. Every pilot has practiced landing with landing gear that's faulty. When particular incidents happen in the aviation world, they build those scenarios into the training because pilots undergo ongoing training all the time. It's part of the job. And so if you look at best practice here, that's a good place to look, is aviation training. And certainly a lot of the safety results that are achieved in aviation can be actually taken back to the use of simulation, which has really been going on for about 40 years plus in that industry. It's also heavily used in military. So this is just one example to give. This is the Portuguese Navy and Lynx helicopters. And you can see it's not a lot of what they do, flying upside down and so on and so forth, even just in training, is quite dangerous. But a lot of the training is done in simulators. So that's an example of a helicopter simulator there with a full 360-degree field of view. In the case of the Portuguese Navy, they train their helicopter pilots in a joint facility in Europe. It's been in service since 1988 and has provided 100,000 hours of training to Lynx pilots. And what the Portuguese Navy's been able to achieve recently was 20,000 flight hours, no aircraft damage, no loss of life, and the people that run that training, so that they couldn't have done that without the incorporating simulation as a part of that for the pilots. So it's certainly well established in those two industries, in civil aviation and in the military world. And in the case of military, not just for pilots, they do this sort of thing for tank training and that sort of stuff as well. And just a couple of little examples for interest as much as anything around the future of where this can go. So the picture on the left here is of an unmanned aerial system. So the UAVs that are used, I guess people are aware of the use of these systems in Afghanistan and so on. The interesting thing about these console stations that they use to fly UAVs is that it's exactly the same system as used for training as is used for flying their real drones. So a guy can turn up for work in Nevada and he may be doing a training exercise today. He'll sit in the same seat as he will when he turns up tomorrow when he flies a real mission. And all the sensor feeds from video, infrared, LiDAR are all reconstructed back on these screens. And there's really no difference to what this person experiences between training and a real operation. And for things that are hard to automate in mining, there's certainly potential to do that. So automating digging machines is technically quite difficult. But if you can get sensors onto those machines that give the feel and the feedback, and you can replicate the responses interacting with the rock, it's absolutely possible to take simulators and use them to control that equipment remotely. So I know one of the large mining companies had made a deliberate decision recently to use a shovel in a backhoe configuration on top of the bench to keep the shovel operator away from automated trucks in case anything went wrong, and took a productivity hit, a known productivity hit, to dig in that configuration, to put the safety parameter in front. But if you could actually make that operation of that digger remote in that sense, you could actually use it down on the same level as the trucks and get a higher productivity. So there's certainly some opportunity with that sort of thing in the future. Another thing that's common in military and increasingly in civil emergency response is off-the-shelf products for operational control that are also used for training. So the picture on the left is a product from a company in Israel that governments and military can buy that allows them to coordinate activities of different parts of the Defence Force. So it might be, Navy, Army, Air Force, but also for, civil emergency response. And a bit like the last example, but broadened out, you can use exactly the same room, equipment, hardware, software for running a training exercise as what you can use for running a real response to an event. So again, with the trend we see in mining with remote operations, one thing that has typically been left out is the training aspect. And absolutely with the technology and the way it's moving, it will be possible to set up these remote operations centres so that people can practice scenarios and be trained on exactly the same environment and hardware and software and data feeds as what they'll experience in the real job. So a couple of conclusions. It's possible to use this benchmarking data to understand where things are at for your particular site. However, you do have to do some work looking at where in the cycle the opportunities may lie. That case study shows that if you use a modern approach to training and blended learning, you can actually get a productivity benefit from that. And simulation, for the future, those investments have potential to be used in real-time operations. I just wanted to make a couple of acknowledgements to people who provided data for me today, which was GBI and Vista Training, which is a US company that did the Suncor work. But that's all I have to share with you today. But I'm happy to take some questions.